5, graphs of sine and cosine functions. So we are going to use our unit circle and first focus just on the cosine of the angle, which is the x coordinate. And imagine taking the circle at each of these values and unwrapping it in order to fit each of these x coordinates on. Now, this should be counting off by 30s. The values are off by 1, unfortunately, so that should be a 30, 60, 90. And then 120, 150, the 180 is here. So my 270 has to move over and my 360 has to come up a little bit. So using the 30-degree increments and counting off, starting at 0, the cosine at 0 degrees is 1. And then as I move to 30 degrees, it is the square root of 3 over 2, which is a decimal point as best as I can get it to be about 0.8 or so. And at 60 degrees, it's at a half or 0.5. So my x scale here, I'm counting off by, or I'm sorry, my y scale here, I'm counting off by 1s. At 90, it goes to 0. And then I'm going to repeat those two numbers again. It's just that they happen to be negative. And so I'm at negative 0.5 at 120, and then my negative 0.8 until I get to 180 degrees where it is at negative 1. And then it repeats in my circle. At 210 degrees, I'm back to negative square roots of 3 over 2, and then I'm back to negative 1/2 at 240 degrees, and I'm back to 0 at 270. At 300, I would be at positive 0.5, and then my 0.8-ish again, and then back to 1 at 360 degrees. And then this again would cycle through. So cosine, as best as I can draw this through, looks like this U shape. And it's remembering again that at 0 degrees, I have a value of 1, a coordinate there. So let's take a look on the calculator. I'm in degree mode. I will go to my y equals and put in the cosine of the angle. I have to arrow up here and turn off my stat plot. And then if I go to my window, I'm starting at 0. We saw what 360 degrees looks like, which only shows us one cycle. If we would continue past 360 degrees, as we've done working to find reference angles, if I go to 390, that's really the same as 30. So if I would keep going, I would continue to see more cycles of this. So let's look at 360 times 3. Let's go 3 cycles out instead, which is 1080 degrees. And I can mark off by 30s to see how that shows up. It only goes from -1 to +1. I'm going to say -1.1 just to give a little bit of padding in the graph. And we can count off by 0.1s if we want, so that it is similar to what we saw. So there's the first one. That would have been 360 to stop. And it's just going to continue on and on and on, doing the same thing over and over and over again. So again, on this window, I went a little bit past 1. So just to 1.1, just so that I had some space there with my curve. But otherwise, you can see it's starting at 0 degrees at a height of 1, and then it's just continuing to repeat. So one full cycle that I'm looking at, though, really is from max to max. So when I hit 1 at 0 degrees, it decreases to -1 and then increases until I get up here to +1 again, which would be at 360 degrees. And I could trace and take a look at all of those if I needed to. Now, sine uses a lot of the same numbers, except it doesn't happen at the same time. And so if I again do my little fix here so that I'm counting off in 30-degree increments. The sine are the y coordinates when you look at the unit circle. So the sine at 0 degrees is 0. And it peaks to 1 at 90 degrees. and then it's going to be 0 again at 180, and then it's -1 at -270, and then it comes back up to 0 at 360. So the same thing happens in between, but just recognizing those important markers where I'm crossing the axis and where my peak, my max is and where my min is. But doing the same exact thing, the sine at 30 degrees is going to be 1/2. Whereas for cosine, it was the square root of 3/2, so it was a little higher. And then now at 60, they switch places because at 60 degrees, my triangle, if I visualize that on the unit circle, is the higher value. And then it starts to decrease again. At 120, I'm back to the square root of 3/2. And then at 150, I'm back to 1/2. So the same thing happens. You can start to see here that it's peaking here, and then it's very much going to resemble cosine after that. Because if I go to 210 degrees, it's just now my -1/2, and then my negative square roots of 3/2. It's at -1 at 270, and then I have negative square roots of 3/2 again, and then -1/2 again. And so if I start here at 90 degrees and draw that curve, it would look like the U that I had of my cosine if it had just been translated by 90 degrees. Because it's cyclical, we're seeing all of those same values. Hopefully your sketch is a little bit neater than mine, but that happens. Okay, so here was cosine. I am going to just go to y equals, not second y equals, turn this off just for a minute and look at the sine of x. And then we'll look at both of them graphed together. So I'm going to keep the same window as what I had before. And I'm just going to see again that it starts at 0, and then it hits and finalizes one full spin of my unit circle, if you will, at 360. So this time, instead of going from max to max, it's really going from x-intercept and then crosses once, goes down below, and then comes back up to the x-axis to complete one cycle before, again, I can see 3 of them in this window. And so it takes 360 degrees to essentially complete the unit circle, if you think of it like that. It takes 360 degrees then to see the entirety of one period of my sine function or of my cosine function. And so if I go back and turn cosine on now, just to take a look, I can again see that they're just off. So it's just been translated. And so I either need to push my cosine to the right by 90 degrees to get it to line up, or I need to take my sine and push it to the left 90 degrees to get this to line up. Now, we graphed everything in degrees. We could have as easily graphed in radians, and then instead of taking 360 degrees, my scale would be up to 2 pi. So if I counted off by pi over 6, because that's equivalent to 30 degrees, and plotted all of those same points, I would see the same thing happening here. Now, that's the focus for our 5.5. But to wrap it up, to look at the tangent, and it helps to be able to look at sine and cosine together whenever we do this, because it is sine divided by cosine, and something that happens here as well. We've seen it on some other work that we've done, some other problems, that if I'm going to take sine divided by cosine at each of these values, then for example at 1, the tangent would be 0 divided by 1, which is fine, that's just 0. But then I'm going to run into issues at, say, 90 degrees, where the sine is 1 and the cosine is 0. So at 90, I would be taking 1 and dividing it by 0, which is undefined. So this actually creates a vertical asymptote, which should be straight, because I have 1 divided by 0, which is undefined. If I look again at some of those key points we had talked about with sine, at 180 it's 0 again, and the cosine is -1. Well, who cares? It's 0 divided by that. So it just stays at 0. But then 270 again is going to give me division by 0. And so 1 divided by 0 is in fact undefined. And so the tangent function, also a little different. Sine and cosine have boundaries. So they are between -1 and +1 for those values. And it is because if you think of SOHCAHTOA with those ratios, it's always either adjacent over hypotenuse for cosine or opposite over hypotenuse for sine. Well, if the hypotenuse is the biggest side, then that fraction is always going to be small divided by big. And so it's always going to be something that's less than 1. When it's equal to positive or -1, that's actually where the triangle collapses. And so you're looking at just the radius of the unit circle. So it's really just that hypotenuse instead. But tangent, that doesn't happen. And so if we have sine increasing, so a bigger number, divided by the cosine, which is getting smaller and smaller, as I take larger and larger numbers and divide them by smaller and smaller numbers, they're actually approaching infinity. And so think of like the sine at 89 degrees. That's a really big number, but the cosine at 89 is a really small number. And so instead, this is going to approach the asymptote almost in an S-curve. It almost looks like a cubic function. So I'm getting higher and higher values as I approach the asymptote, and it's approaching negative infinity from the positive side. So this, again, that idea of approaching. So I know that we didn't do this one with the table as neatly as we should have, just to get some idea of it, but to keep our video length reasonable. And I wanted to take a look at the calculator for a much nicer picture of this. So let's clear out sine and cosine this time. And let's take our window, because it doesn't take a full 360 degrees in order to see the entirety of the tangent function. Let's just look at -360, or I'm sorry, look at 360 for the max instead. And so when we graph the tangent of x, we can see that it's increasing, and then it doesn't show my vertical asymptotes, but then I can see that the next one's kind of increasing. The next one's kind of increasing. It doesn't look like as much of an S-curve, but let's adjust this window again. And so let's do 720, so 360 times 2. And then let's go from -10 to 10. So that we can see a little bit more. We can count off by ones of what would happen here. So now it looks like a little bit more of that S-curve, because I can see as it's approaching those asymptotes, it's getting higher and higher. And it, again, to see one period of it, it only takes 180 degrees, because then we are repeating. And we talked about this with the unit circle. In the first and third quadrants, those tangent values are the same, because you have 2 positives, or in quadrant 3, you have 2 negatives, which give the same positive answer. And then in quadrants 2 and 4, the same thing happens. And so that's where we see that repetitive cycle, and why we only need the 180 degrees as opposed to the 360. So again, sine, cosine, and tangent, just graphically, but again, pulling from the ever important unit circle. Obviously nicer pictures on your calculator than what we have here, and you doing it by hand a bit more accurately would help an awful lot too, to give you a cleaner copy.